Good afternoon, everyone. My name is Ekaterina Moskvina. The topic was already named, and my work was focused on the comparison of the two design approaches, the traditional one or code-based and the performance-based, when they are applied in the initial stage of design. Additionally, I investigated the readiness of the performance-based design approach to substitute the conventional way of work. What is the difference between these two approaches? Um, the traditional approach focuses on the compliance with building codes. The main objective of building codes and standards are to keep people safe, prevent unpleasant consequences of different levels of accidents. However, this is not enough now when the construction complexity and velocity grew amazingly. And on this slide, you can see sustainable development goals that how construction sector can contribute and the actually challenges that that are construction sector faced now. Um, so performance-based design is an approach that intends to create a high-performance building that will be energy efficient, that will be comfortable for occupants, as cheap as possible in the construction, low cost in maintenance, and everything that we used to call green building or green architecture. In other words, the performance-based approach is goal-oriented, in opposite to the conventional method of design. The work consisted of three parts: a literature review, survey, and practical case study. Throughout the literature review, the main issues of implementation performance-based design on the early stage of design were identified. It is an absence of a clear and straightforward system of performance objectives, as well as absence of reliable methodology or strategy for the performance analysis in the beginning of the design, absence of simple methodology for multi-criteria assessment. The literature review was also a basis for the second part of my study, an online survey among 43 design companies from 20 countries. The main goal of this survey was to understand the current picture of awareness and acceptance of the performance-based approach in practice. The survey consists of two parts: demographical information, main data about the company size, type, their experience, and the second part with 10 statements where respondents should agree or disagree with each statement on a scale of 1 to 5. The survey results show that although many research works were done on this topic, at least 20% of practitioners are still not familiar with the concept of performance-based design. Only half of the respondents use the performance-based approach, despite the fact that 86 of them use BIM. The reasons why they don't use were starting from they don't know what is the approach, it is too complex, it takes too much time, or just client didn't ask about it. The result of the second part of survey show the attitude of professionals to the benefits and disadvantages of performance-based approach in the early design stage. We can see that in general, architects and engineers who use this approach are aware of benefits it brings to the early design stage. Although not all statements were rated unambiguously, not all respondents agreed that performance-based approach helps make decisions faster or improves the quality of designers' expertise faster. On the other hand, the implementation of this approach still has multitude challenges, such as methodology for choosing performance objectives or selection process during the optimization phase, where the results of survey are not so obvious. The red bar chart shows this clearly. The last part of the study was the practical experimental application of performance-based design on a hypothetical project of an office building in Menges, Slovenia. It was intended to identify issues with the application of a performance-based approach in BIM from designer's point of view and compare this approach to the traditional one. For both methods, the same tools were used. It's Revit, Autodesk Revit for modeling, and Cove Tools platform for analysis and optimization. Uh, Firstly, for both methods, were set the requirements. Its type of the building, its location, its total area, um, uh, starting window to wall ratio, and yeah, site. The conventional approach test was done in the beginning to exclude the influence of knowledge gained during the performance-based design. You can see now the two workflows, and you can see the difference uh, of conventional approach and performance-based design approach. Um, let's go to the results. For first part, for traditional approach, the results of the conventional approach design was the model of a two-story building with a total area of 9,600 square meters, with simple layouts and analysis results that are presented on the slide. For the performance analysis during the performance-based approach, more than one model was created because it implies more than one analysis cycles, as you can see. Uh, in overall, there were four analysis cycles. It was shape, orientation, glazing ratio, and glazing distribution as the design options were analyzed uh, and selected the best option for each design parameter. Um, why we selected these parameters? Because these are the most difficult to change at the later stage of design. And you can see that each of them has the particular design goals, such as lowest energy consumption or utility cost or highest SDA. Um, so, using this strategy, we obtained the following results. For shape, it was the long shape showed the best result in terms of performance. Orientation was from east to west. Glazing ratio was 35%, and glazing distribution was not 50, was evenly distributed on two sides, northern and southern. Why don't we see the design in this case? Why don't we see the model? Because the results of this approach is not the design itself, but the knowledge of which value of each design parameter will perform in the best possible way. Also, we know how the performance will change. For example, if you start increasing the height of the building or change its orientation. When we comparing the performance analysis results of the two methods, we can see that the result for energy consumption and daylighting performance are way better for performance-based approach than for the traditional. Although both energy use intensities are lower than the baseline, the value of performance-based design option is much closer to the 2030 target. For spatial daylight autonomy SDA, the highest value is better, and for annual sunlight exposure ASE, the lowest. And for both, performance-based design option showed better results. In the case of utility cost, it was the opposite, but there could be the reasons such as not uh, high accuracy of the tools, also different level of development of models. When we comparing the results on the basis of time spent, the total time for conventional approach was 6 hours. For performance-based design, it was 18 hours. But in overall design process, this difference is not that significant. Moreover, in the case of traditional design, we don't know if this is the optimal solution for this project and how the performance can change. We checked just one option. In case of the design modification, and a new analysis should be conducted to understand how the changes influence the building performance. And in this case, time difference will be reduced. Oops, sorry. So, for the conclusions, all three parts of this work, literature review, survey among practitioners, and practical study, made it possible to research the existing picture of implementation and use of performance based design in the early design stage in depth. Um, the performance based design should not be considered as the substitution of conventional approach, but it should be considered more as an additional input of data-driven parameters that should improve the architectural work significantly. The second conclusion was that we can make after this work that the major benefits of the performance-based approach application in the initial stage of design, even before the design, is the ability to explore a wide space of options in terms of future performance and support architects with valuable data when the greatest impact on the performance can be done with the lowest cost. And another conclusion that was made after this work is that even though performance-based design can provide data about future performance, its interpretation and subsequent impact on the building design are solely in the designer's hands. In other words, data is worth only if it's understood correctly. And here we can see the necessity of change of current structure of design offices, design processes, and how designers and engineers are educated. Yeah, that's it. Thank you for attention.